Okay, last time we met, we were talking about vertical and horizontal transformations. Today we are going to do vertical stretches, vertical compressions, and reflections. So I'm just going to start out here by graphing the parent function. Vertex is at 0, 0. Our coordinates for 1 are positive 1 and negative 1 are positive 1. If you put in a 2 and you square it, you get 4. And using the reflection property, or the reflection property of symmetry, we can reflect it across the line of symmetry, axis of symmetry, and get a point similar to the other side. And then I'm just going to use a dashed line here to represent the parent graph. Should look something like this. And our function is going to be f of x equals x squared. Okay, there's our parent graph. Now we are going to stretch this one by a factor of 2. So again, our vertex is going to be at 0, 0. So if I go over 1, our output normally is 1. Let me just go ahead and label these, what my points should have been. And so if I'm taking 1 and multiplying it by 2, that makes our input as 1 and our output will be 2 because it's growing twice as fast. On this one, if I multiply it by 2, I get 8. So if I go over 2 and 8, well, this really only goes up to 7. So I normally would not graph outside the graph, but this is just for demonstration purposes. So I'm going to go up. Approximately there, and then just graph them together, connect all of those points. Come on. Oh, I guess needs. Oh, come on. Nope, I don't. Okay. I just love allergies. Okay, so we'll connect all of those. And now our function is going to be g of x. Oops, I should have put down g of x instead of f of x. Is going to be 2 times whatever our x squared is. Okay, so we're doubling it. Our vertex is still occurring at 0, 0. Our axis of symmetry is still x equals 0. Now let's move over to our next function. Actually, we're going right down here, stretch. Stretch is when a is greater than 1, okay? You have compression if a is less than 1, or a compression if it's between 0 and 1. So if you have a fraction, it's going to be compression. All right, so this time, our new function is going to be negative x squared. So again, I just plot out my parent graph here. I know some of them put the parent graph on and others did not. Okay, so we're going to take that and we're going to take every one of our values, our outputs, and we're going to change the sign of it. So when we put in 0, 0 times 0 is still 0. So our vertex is going to be the same. But now when we take a positive 1 and multiply it by a negative 1, we get a negative 1. When we put in a positive 2 and square it, we get a positive 4. But then the opposite of a positive 4 is a negative 4. So we're just going to graph those points and then use the properties of symmetry to graph the other points that coincide with it. So it's just reflected across the x-axis. You want to make sure that you let the people know which axis you are reflecting it across, because there are 3 axes. There's the x-axis, the y-axis, and then eventually you will learn about z-axis, just not in this class. Okay. All right. So now we have a compression. So if I graph my parent function, 1 and 1, 2 and 4, and then use that property of symmetry. I'll mark that my parent graph this time is going to be a solid line. Okay. And now we're going to come over here to find out what we would do. So if my output is 0, 0 squared, well, 1/2 of 0 is still 0. 1/2 of 1 squared would be 1/2. So I'm going to put a little point, approximately where 1/2 would reside. And then 1/2 of 2 squared would be 2. And then 1/2 of 3 squared would be 4.5, because 3 squared is 9. Half of 9 is 4.5. Put a point right there. We're going to use the properties of symmetry to find the other half of my graph. So over 1 and up 1/2, over 2 and up 2, over 3 and up to about 4.5. 4.5. So I should have a matched set of dots when I look at it. Okay, we can see that that is growing half as quickly as our parent function. Okay, so g of x equals 1/2 x squared. We did a vertical compression of a factor of 1/2. Okay. Vertical compression factor 1/2. Okay, vertex is still 0, 0. Axis of symmetry is x equals 0. All right, now we have our parent function. Our parent function again is graphed as the dash. And if you need to see, you can check to see what's going on. All right, now we're going to see what happens on our solid one. So a is greater than 1 because when I went over to 1, I was expecting to get a 1, and instead I got, a vertical stretch. And we use 1, which is very easy because it'll tell us what our factor is. So I was expecting a 1, I got a 4, so it stretched by a factor of 4. So g of x equals 4x squared. Vertex is still occurring at 0, 0, and my axis of symmetry is x equals 0. Okay, now we have this one. Remember, our parent function is going to be the dashed one. And you can verify that by looking at the lattice points. If you go over 1, you should end up on 1. If you go over 2, you should end up on 4. Okay, so we're going to see what happened. Did not get shifted up or down. Did not get shifted up or down. We can see that it's outside our graph. So if I go over 1, I can't tell. So if I go over 2, am I on a lattice point? What they also call a pretty point, or a where you would go over and say, you know what, I need to be at crosshairs. So I was expecting 4. I ended up with 2. So what do we do to a 4 to make it a 2? Well, we divide it by 2, so it is growing half as quickly. If I come over to 3, I should end up at about 4.5. I do end up at about 4.5. So, wondering why they put 2 of them on here the same. Why would they put two of them on here being exactly the same? Well, I don't know. I'm going to go back and look at that other one here in just a minute, because I can see that this one is growing half as quickly. I went over to 3. I was expecting 9. I'm ending up at 4.5. Let's go back and look at that one just really quickly. All right. Let's go back and look again. Oh, I'm having a bifocal moment there. That was supposed to be 1/3 on that other one. Okay, so this one is indeed x squared. I mean 1/2 of x. You know, I could have just edited this out, but I figured that this was a teachable moment. So I ended up with 2, 2. I ended up with 3 and 4.5. So it is going at 1/2 the rate. So it is a vertical compression. So my function should be g of x equals 1/2 x squared. My vertex is still occurring at 0, 0, and the axis of symmetry is x equals 0. Okay, and then finally this one. Remember, the parent graph is the dashed one. We can see that our new graph is inside, which means it is a vertical stretch. I'm going to look for my lattice points. One's not going to help me. Let's see, is 2 going to help me? Maybe. Okay, there we go. 1 is going to help me. I just had to look at it a little bit better. And then 1 goes up to 2. So we're going to have a vertical stretch of 2. Okay. Function g of x equals 2x squared. Vertex is going to occur at 0, 0, and our axis of symmetry is x equals 0.